Hi, welcome back. This is Mrs. Lewis's physical science class. You are on chapter 2, and this is lesson 1. So you should be on PS 2.1. And right here, you already have automatically off the top vocabulary. So please write that down. Motion is the change in an object's position relative to a reference point. Displacement is the distance and direction of an object's change in position. So if we talk about adding displacements, so a displacement, another vocabulary word, in the same direction can be added. So for example, instead of looking at it like this, let's look at it as an addition problem. Because we're going in the same direction, east, and then we continue walking east, we're going to take 5 meters plus 5 meters, and it equals 10 meters east. You have to include this with the displacement. Now, displacements in opposite directions can be subtracted. Make sure you're copying all of this down. For example, if you walk 10 meters east and then 5 meters west, the size of your displacement is what? It's 0. Displacements that are not in the same direction or in opposite directions cannot be directly added or subtracted. So for example, make sure you're drawing this on your paper. If you walk 4 meters east and then 3 meters north, your displacement is 5 meters in a roughly northeast direction. But the total distance traveled is 7 meters. So, speed, here's another word, is the distance an object travels per unit of time. So how do we calculate speed? Make sure you're adding this. Calculating speed is any change over time is called a rate. If you think of distance as the change in position, and then speed is the rate at which distance is traveled or the rate of change in position. So the speed equation, I'm going to want you to do the long way and the short way. So speed, which is always in meters per second, and distance, which is always in meters, and time, which is always in seconds. Okay? So the simple formula to that is speed equals distance over time. This will be on your quizzes. This will be on your test. You'll need to know how to calculate speed by giving me that, okay? And you'll also be required to calculate a problem. And let's do one together now in your notebook. So the problem, write down, a car traveling at a constant speed covers a distance of 750 meters in 25 seconds. What is the car's speed? Well, the first thing I tell everybody, analyze the problem, because you don't know what to do if you don't analyze it. I had a hard time with word problems, and sometimes I still do. But I find if I come in and I highlight what I know, then it's easier for me. So what do I know? Well, I know the distance, and that was 750 meters. And I know the time, that was 25 seconds. So since I know, in order to learn about speed, I have to take distance and divide the time, I can set up my problem. So it's 750 meters divided by 25. And when I take my calculator and I divide that, it tells me that's 30 meters per second. Do not forget this part, otherwise your answer would be wrong. So when we evaluate the answer, 30 meters per second is approximately the speed limit on the interstate highway in the United States. So our answer here is reasonable.
A graph gives us another way to describe an event. This graph of distance versus time tells the story of a girl named Chris and her dog during an 8-minute walk. As Chris and her dog move farther from home, the graph line moves upward. When they stop, their distance from home is not changing. The graph line moves upward again as Chris and her dog start walking again. The graph becomes horizontal, telling us that they have stopped again. Chris and her dog have now turned toward home. The steepness of the graph tells us that they are moving faster, probably running. At the end of the walk, 8 minutes have passed, and the distance from home is again 0.
So in class, we'll view that movie again so I can discuss it further. But what you just saw was a distance time graph. So in your notes, please write down distance time graph. And then you're going to draw this table exactly how you see it. Now, if you do not have colors at home, you can actually use the red one and you can just do dashes. You can draw a straight line for the blue, and for the green you can do like maybe circles, little circles along the way. And I want you to do this exactly how you see it. Please leave 2 to 3 lines underneath or above your graph, however you set it up, so that I can have you add some notes in class. So changing speed, that's your next bullet point. Usually speed is not constant. Please write this down. How does the slope of the graph change when you speed up and slow down? What happens to the graph when you travel at a constant speed or stop? So this is another graph that you will need to build. As far as I'm concerned, you don't need to mess with this. You don't need to mess with this. I don't want to see any grids, okay? So as long as you are doing these slopes. So here we go. As we're changing speed, we're sloping, and then all of a sudden we take a dive, and then all of a sudden we take a dive, and then we come up again, and then all of a sudden for the first time we have a straight line going from left to right. It's horizontal, horizon. Okay? And then it comes back down. Well, what does all that mean? For the purpose of your test, you have to know this. I'm going to be giving you graphs like this, and you need to be able to tell me, Mrs. Lewis, when it's curving upwards this way, it's gaining speed. And when it comes down right here, it's falling. And then we're going down and we're climbing, we're stopping at some point. And then this is constant speed. So whenever you see a horizontal line, this means constant speed. Whenever you see something moving up, that's gaining speed. Whenever you see something moving down from an up point, it's because it's going down. So label them as such. Please go ahead and copy down this slide. Average speed. Average speed describes speed of motion when speed is changing. Average speed is the total distance traveled divided by the total time of travel. So if the total distance traveled was 5 kilometers and the total time was a quarter of an hour or 0.25 hours, the average speed was 20 kilometers per hour. Go back up for a minute to the graph for graphing motion that you've already drawn out, and here's what I want you to add. The motion of an object over a period of time can be shown on a distance time graph. Time is plotted along with the horizontal axis of the graph, and the distance traveled is plotted along the vertical axis. And because I know we still struggle with a little bit of these words, horizontal means going from left to right. So if we're moving from left to right, this is the distance traveled. And if we're moving in this direction, anything that's other than left to right, if we're moving up this way or if we're moving down this way, that is a vertical axis, and that is showing us also the distance traveled. Okay, go ahead and write this down. Graphing motion. Once the scales for each axis are in place, the data points can be plotted. And after plotting the data points, you will be drawing a line in order to connect the points. All right, so now you can leave that one section and go to the bottom of your notes, and we're going to add speed on distance time graphs. So the graph that you're looking at shows that the line representing motion of the faster swimmer is steeper, and that would be Mary. An object's speed is equal to the slope of the line on a distance time graph. Make sure your notes are complete, and we'll be reviewing this tomorrow. If you have questions, write them down so then when I come check your notes, I can answer them. Thanks.